Okay, we're up to module 11 of ENSA, which of course is network design. So we're going to explain the characteristics of scalable network architectures, and so we're going to look at hierarchical networks and how data, voice and video can converge on one of those networks. We'll look at scalable networks, so in other words, one that can grow and not grown. Switch hardware, so we'll look at what switch hardware is available to support whatever requirements you might have, as well as router hardware, so again to support whatever network requirements you might have. Okay, so hierarchical networks. So organisations increasingly rely on network infrastructure to provide mission critical services. So evolving organisations require networks that can scale and support converged network traffic, critical applications, diverse business needs, and centralised administrative control. Campus network designs include small networks that use a single LAN switch up to very large networks with thousands of connections. So Cisco has a system called the Cisco Borderless Network. It's a network architecture that can connect anyone, anywhere, anytime, on any device, securely, reliably and seamlessly. It provides a framework to unify wired and wireless access built on a hierarchical infrastructure of hardware that is scalable and resilient. Borderless switch networks are hierarchical, modular, resilient and flexible. Okay, so the hierarchy within borderless switch networks. So hierarchical networks use a tiered design of access, distribution and core layers, with each layer performing a well-defined role in the campus network. And so there are two time-tested and proven hierarchical design frameworks for campus networks. So for larger networks, you would actually have the three tiers where you have the core, the high-speed core of the network, the distribution layer, which is where most of your routing will happen, and then the access layer, as the name implies, that's how your users access the network. And so that's mostly layer 2 switching and or wireless access points there. And then, of course, layer 3 routing, and then core layer can either be routed layer 2 or layer 3, but its major thing is speed. Now, for smaller networks that don't need all three tiers, you can combine the core and distribution layers together to save on hardware if there's no need for all that extra hardware. So the access layer provides network access to the user. Access layer switches connect to distribution layer switches. Now, the distribution layer implements routing, quality services and security. It aggregates large-scale wiring closet networks and limits layer 2 broadcast domains. Distribution layer switches connect to access layer and core layer switches. And so basically, of course, it's layer 3 switches are what they're talking about here. And so, of course, because they're behaving as a router, they stop the transmission of broadcasts, or limit the transmission of broadcasts. And so, of course, and then the middle layer between the access layer and the core layer. So the core layer is the network backbone and connects several layers of the network. The core layer provides fault isolation and high-speed backbone connectivity. Okay, so three-tier campus networks are used by organisations requiring all three layers. The recommendation is to build an extended star physical network topology from a centralised building location to all other buildings on the same campus. With a two-tiered one, you can use when a separate distribution core layers aren't required, as I said, for a smaller network. Useful for smaller campus locations or in campus sites consisting of a single building, also known as the collapsed core network design. All right, so the role of switch networks. Networks have fundamentally changed from a flat network of hubs to switched LANs in a hierarchical network. A switched LAN allows additional flexibility, traffic management, quality of service and security. A switched LAN may also support wireless networking and other technologies such as IP, telephones and mobility services. Now, scalable networks. So scalable is a term for a network that can grow without losing availability and reliability. So network designers must develop strategies to enable the network to be able to scale effectively and easily. This is accomplished by using redundancy, multiple links, scalable routing protocol, and wireless connectivity. Okay, so redundancy can prevent disruption of network services by minimising the possibility of a single point of failure by installing duplicated equipment, and provide failover services for critical devices. Redundant paths offer alternate physical paths to data to traverse the network, supporting high availability. However, redundant paths in an Ethernet network may cause logical layer 2 loops, and so of course we need spanning tree to save the day in that regard. And so a well-designed network controls traffic and limits the size of failure domains, so i.e. the area of a network that is impacted when a network experiences problems. In hierarchical design model, failure domains are terminated at the distribution layer. Every router functions as a gateway for a limited number of access layer users. Routers and multi-layer switches are usually deployed in pairs in a configuration referred to as a building or departmental switch block. Each switch block acts independently of the others. As a result, the failure of a single device does not cause the network to go down. So link aggregation. So Ether channel allows an administrator to increase the amount of bandwidth between devices by creating one logical link made up of several physical links. And so it combines existing switch ports into one logical link using a port channel interface. Most configuration tasks are done on the port channel interface instead of the individual physical ports to ensure configuration consistency. An Ether channel can load balance between the links. And also, of course, spanning tree treats it as one link, and so it won't be disabled. So this would be a switching loop if they were separate, but because they're bound together in an Ether channel, they're treated as one link. Okay, so expanding the access layer. An increasingly popular option for extending access layer connectivity is through wireless. Wireless LANs provide increased flexibility, reduced costs, and ability to grow and adapt to changing network and business requirements. To communicate wirelessly, end devices require a wireless NIC to connect to a wireless router or a wireless access point. Considerations when implementing a wireless network include types of wireless devices connecting to the wireless LAN, wireless coverage requirements, interference considerations, and security considerations. Okay, then we've got tuning of routing protocols. Advanced routing protocols such as OSPF, or Open Shortest Path First, are used in large networks. So OSPF is a link state routing protocol that uses areas to support a hierarchical networks. OSPF routers establish and maintain neighbour adjacencies with other connected OSPF routers. OSPF routers synchronize their link state database within an area. When a network change occurs, link state updates are sent informing other OSPF routers of the change and establish a new best path if one is available. Okay, switch hardware. So there is a variety of switch platforms, form factors and other features that must be considered before choosing a switch. When designing a network, it is important to select the proper hardware to meet current network requirements, as well as to allow for network growth. Within an enterprise network, both switches and routers play a critical role in network communication. So campus LAN switches, such as the Cisco 3850 series shown here, support high concentrations of user connections with speed and security appropriate for the enterprise network. Okay, so there is Meraki, which is a cloud managed access switch, enables virtual stacking of switches. They monitor and configure thousands of switch ports over the web without the intervention of an on-site IT staff. Cisco Nexus platform promotes infrastructure scalability, operational continuity, and transport flexibility in the data center. Okay, so service provider Ethernet access switches feature application intelligence, unified services, virtualization, integrated security, and simplified management. Cisco Nexus virtual networking switch platforms provides secure multi-tenant services by adding virtualization intelligence technology to the data center network. Okay, so form factors. When selecting switches, network administrators must determine the switch form factors. This includes fixed configuration, modular, stackable, and non-stackable. Features and options on fixed configuration switches are limited to those that originally come with the switch. The chassis on a modular switch accepts field replaceable line cards, and so it makes them very, very flexible. So special cables are used to connect stackable switches that allow them to effectively operate as one large switch. So basically these special cables here connect all the switches together in a loop, and it basically brings their backplanes together so they as it says, they behave as one large switch. The thickness of the switch, which is expressed in the number of rack units, is also important for switches that are mounted in a rack. For example, the fixed configuration switches shown in the figure are all one unit high, and so that, of course, means you can pack them pretty densely. The port density of a switch refers to the number of ports available on a single switch. Fixed configuration switches support a variety of port density configurations, and so you can have 12, 24 and 48 port configurations for that 3850 that's on the screen. Of course, modular switches can support very high port densities through the addition of multiple switch port line cards. The modular Catalyst 9400 switch supports 384 switch port interfaces. As you can see, each one of these is actually an add-on card that you can add. So, of course, you're not talking about bargain basements by any measure, but it certainly does give you a lot of added flexibility. You can add different cards for different purposes. Okay, forwarding rates. They define the processing capabilities of a switch by rating how much data the switch can process per second. Switch product lines are classified by forwarding rates. Entry-level switches have lower forwarding rates than enterprise level. If switch forwarding rate is too low, it cannot accommodate full wire speed communication across all of its switch ports. Wire speed is the data rate that each Ethernet port in the switch is capable of attaining. Data rates can be 100, 1 gigabit, 10 gig or 100 gig. Access layer switches typically do not need to operate at full wire speed because they are physically limited by their uplinks to the distribution layer. Power over Ethernet is something else a switch can provide. And so basically you can power some of your smaller devices from your switch, and so you don't need an extra power point, you just need the data link. And so IP phones, access points and cameras are common things that use that. Network administrators should ensure that PoE features are actually required for a given installation because switches that support PoE are more expensive. Multi-layer switching. So multi-layer switches are typically deployed in the core and distribution layers of an organisation switch network. They support some routing protocols and forward IP packets at a rate close to that of layer 2 forwarding. Multi-layer switches often support specialised hardware such as application-specific integrated circuits or ASICs. ASICs, along with dedicated software data structures, can streamline the forwarding of IB packets independent of the CPU. So it's all done in specialised hardware basically right next to the switch ports. All right, so switch selection, there's quite a few things you need to consider. Cost is always a consideration. So the cost of a switch will depend on the number and speed of the interface's supported features and expansion capability. Port density, of course, is how many ports per device. Power, it is now common to power access points, phones and compact switches using power over Ethernet. And so you can also consider redundant power supplies for your switches as well. So you can basically have a separate DC power supply and keep the switch going even if the AC fails. Reliability, so the switch should provide continuous access to the network. Port speed, so of course again that's a requirement that you need to nail down so that things aren't too slow or you're paying too much for high-speed ports. Frame buffers, the ability of the switch to store frames is important in a network where there may be congested ports to servers or other areas of the network. And so they need enough RAM so they can actually buffer enough packets. Scalability, and so the number of users on a network typically grows over time, therefore the switch should provide the opportunity for growth. So if you've got 20 users, a 24 port switch is not necessarily going to be a great solution. So you might want to buy the next size up just so that you don't have to buy another switch later. All right, router hardware. Routers use a network portion or the IP address to route packets to the proper destination. They select an alternate path if a link goes down. All hosts on a network specify the IP address of the local router interface as their default gateway. Routers also serve other beneficial functions as follows. They provide broadcast containment by limiting broadcast to the local network. They don't forward broadcast, in other words. They interconnect geographically separated locations, so they have lots of options when it comes to interfaces, and so of course you can plug WAN links into them. Group users logically by application or department within the company who have command needs or require access to the same resources, and they provide enhanced security by filtering unwanted traffic through access control lists. So branch routers shown in the figure optimise branch services on a single platform while delivering an optimal application experience across branch and WAN infrastructures. And so these are ISR 4000 series routers that are in the picture. Then we have getting bigger network edge routers shown in the figure enable the network edge to deliver high performance, highly secure and reliable services that unite campus, data center and branch networks. And so these are called ASRs, or aggregation services routers, and they're 9000 series. Then service provider routers shown in the figure deliver end-to-end scalable solutions and subscriber-aware services. And so the Network Convergence System, or NCS, 6000 series routers. Pretty big piece. Okay, so industrial routers such as the ones shown in the figure are designed to provide enterprise class features in rugged and harsh environments. Shown are Cisco 1100 series industrial integrated services routers. And so a 900 series, this is a small branch office router. It combines WAN, switching, security and advanced connectivity options in a compact, fanless platform for small and medium-sized businesses. So as you can see here, we've got 6 ports. And of course you can configure which one is outside and inside and the like. So the ASR 9000 and 1000 series aggregation services routers, they provide density and resiliency with programmability for a scalable network edge. And so the provider ones, these routers are designed to efficiently scale between large data centers and large enterprise networks, web and service provider WAN and aggregation networks. And so the 800 series industrial integrated services router, it's compact and designed for harsh environments. Okay, so that is the end of the chapter, just the summary to go. And so what did we learn? So the borderless network provides the framework to unify wide and wireless access and is built on a hierarchical infrastructure of hardware that is scalable and resilient. Two proven hierarchical design frameworks for campus networks are the 3-tier and the 2-tier layered models. The 3 critical layers within these tiered designs are access, distribution and core. You can implement redundant links between critical devices and between access layer and core layer devices. Implement multiple links between equipment with either link aggregation like Ether channel or cost load balancing to increase bandwidth. Use a scalable routing protocol and implementing features to minimize the routing table size. And you can implement wireless connectivity to allow for mobility and expansion. There are campus LAN, cloud managed data center, service provider and virtual networking switches. Not witches. Form factors for switches include fixed configuration, modular configuration and stackable. If routers use the network portion of the destination IP address to route packets to their proper destination, and so they can select an alternate path if the primary path goes down. And Cisco has several categories of routers including branch, network edge, service provider and industrial. There is the logo, and so that is all for now. I'll see you next time with Module 12. Have a good one.